Okay, so this is my lab report on Lab 8, Kirchhoff's rules. Alright, so the main goal of this lab was to calculate currents going through a circuit using Kirchhoff's rules. The way you do that is by making 3 equations derived from the circuit. I think it's 1 equation from the loop rule and 2 equations from the junction rule, or vice versa, something like that. I think you can go both ways. And using those equations, it's going to be some pretty intense algebra, which we got some help from using a program that was provided to us, and that will allow you to calculate current. We then measured current and compared it to the calculated values to both confirm the validity of Kirchhoff's rules and to figure out exactly what direction the current is flowing in the circuits. So starting off in the pre-lab, we used a digital multimeter as an ohm meter to measure the resistance of the 3 resistors that we had, and then we used that ohm meter again to measure the resistance of any of the wires we were going to use for the experiment to find the average resistance, which could then be added to the equivalent resistance so that we had the most accurate measure possible whenever we were doing calculations with the circuit that we were going to assemble. Now moving on to the lab, we set up 3 primary circuits that we were going to be investigating the voltage of, and then separately from that we as a class came up with 3 different equations for the circuit that we we're focusing on for the pre-lab. Says that the first equation was made using the junction rule and the other 2 were made using the loop rule. And then using the program that we were provided, we inputted those equations into the program, and it calculated the current for us so that we didn't have to do all the algebra. And then we compared those calculated values from the program to values that we calculated ourselves by taking measurements of the voltage and the resistance just to see how well they lined up with each other. So we see here a table of the measured resistance for not only our 3 different resistors, resistor A, B, and C, but also the average resistance of the wires that we were using for this lab. Here we have a couple of things. On the right, the images aren't very good, but those are the 3 circuits that we used to measure voltages. The top one is basically just the battery hooked up to the meter. The second one is it's got a resistor in it, so it will have a little bit of change there. And then the bottom one, it's a little bit more complex. It has some batteries that are opposing each other along the side of a resistor. On the left, you can see the table that has the measured voltages. So the one with just the battery, the voltage came out to be 1.5 volts. The second one with just the current came up with 1.3 volts, and then the one on the bottom there, the third circuit, it had a voltage of 1.6. So here we have a couple of things as well. There on the right is the circuit that we focused on in the pre-lab, and the main one we were going to focus on for this lab. On the left here, you see the table of the 3 equations we came up with as a class. The first equation is the equation derived from the loop rule, and the second and third equations were derived from the junction rule, which all came from that circuit on the right there. This is the table showing the calculated values for the different currents using the program. You see there the first current came out to be a negative value. The reason it's negative tells us that the current was inputted basically in reverse of how it actually flows. So if it was inputted going clockwise, then since it gave us a negative number, it means it's actually going counterclockwise. That's what I mean by that. And finally, here we have the table comparing the calculated currents from the program there on the right to the measured currents that we technically still calculated. We calculated by hand by taking measurements of the voltage and resistance and using Ohm's law to calculate the current. And you can see here it shows both the measured and the calculated currents show that the first current is in fact backwards from how it actually is, and that's what those values are, negative. And then the second and third currents are also very similar to each other. So yeah, with that we can confirm that Kirchhoff's rules does work, and it tells us a little bit of something about how to know what direction the current is flowing in. That's it.